All right, so we're going to take a look at section 3.1. This week, we're going to do two sections. One section in chapter 3 and one section in chapter 4. Chapter 3, what we're going to do, it's on inverse trig. Chapter 4, that's on what we call right triangle trig. How many people have done like opposite, adjacent, hypotenuse, that kind of stuff? Yeah, that's right triangle trig. All right, so we'll look at that tomorrow and Wednesday. Right, first, we're going to start out with something you need to use when you do right triangle trig, and that's inverse trig. Okay, so basically, anytime you do something in math, there's always a way to go backwards. Right? Like if I took a number and I added 3 to it, how could I reverse that? What's the opposite of adding 3? Yeah, subtracting 3. All right, say if I took a number and multiplied it by 5. I could divide it by 5 and go exactly back to what I started with. Another example is if I took a number and squared it. What's used to undo squaring something? Square root. All right, so for most things you do in math, there's a way to undo it. Well, let's say I took sine, let's do this in degrees. Okay, I took the sine of 30. Okay, the answer is 0.5. Well, there's something I can do to 0.5 to go get this answer back. I can undo what I just did. And that's called inverse trig. All right, so let's just start off with the symbol, okay, how you write it. That's the symbol for inverse sine. It looks like sine with a -1 up high. I think what's confusing about this is you'd think this is where you put an exponent. This -1 is not an exponent. It's just, that's where they put the number, it's just a symbol for inverse sine. What's even more confusing is if you put any other number here other than a -1, if you did something like this, that too is an exponent. All right, so it's just when you put a -1 there, just think, okay, nothing to do with an exponent. It just means inverse sine. An older way that they used to write inverse sine is like that, arc sine. Okay, you might see that in your book. They'll mention it, but calculators, most of the modern stuff, we're going to use sine to the -1. Okay, we also have inverse cosine, and that's the symbol for it. Cosine with a -1 up high, or you can write arc cosine. And lastly, we have inverse tangent. On your calculator, you have buttons for all 3 of these. So for what I showed today and what I explained, the directions are going to apply to this kind of calculator. If you've got the TI-30. Okay. Or if you've got a graphing calculator, it'll work on this as well. Okay. Sometimes if you've got one that's a little different, like if you use this one for homework, this one's, and put it like this, this one's kind of weird. Right? So I'm not going to use this one today, just it's not as easy to use. All right, so let's try this. To get to any of these functions above the sine, the cosine, and tangent, which is what we want to use, you got to press second. Okay, so on my calculator or the scientific one, if you press second and you press sine, that gives you inverse sine. If you want an inverse cosine, you just press second cosine or second tangent for inverse tangent. Now, what do you think I'd get if I typed that in? I took the sine of 30 and I got 0.5. What if I take the inverse sine of 0.5? What do you think I'm going to get back? Yeah, I'm going to get 30 back. All right, so it's just like plus 3 minus 3. You're just changing it back to what you started with. Okay, any question on that? Right, as we go on, I'll explain when you'd use inverse trig. For today, we're just going to practice calculations. Tomorrow and Wednesday, you'll actually see how we use it in a triangle. Okay, but we're not going to get to that today. All right, so just copy this down, and then I'm going to show you something, and we'll come back to this. Okay, anytime that you press inverse sine inverse cosine or inverse tangent, I can guarantee you the answer your calculator is going to give you is going to be between two certain numbers. Okay, for sine and cosine, it's different numbers, but I'm going to show you how we can figure out what our answer is always going to be between and why that's important. All right, so let's just watch this part. You don't have to copy this table down. Just watch what I type in. Okay, I've got some different angles, and I'm going to type them in and find the sine of them. The first one we already did. Okay, the sine of 30 comes out to 0.5. It's 0.5. Okay, next I'm going to find the sine of 65. Okay, so I got sine 65, and I get about 0.91. Okay, we just round it off. And let's do sine of 90. Sine of 90, and we get 1. Okay, questions so far? So what would happen if I typed in inverse sine of 1? What would I get back? 90, yeah. If you type in one of these numbers on the right and use inverse sine, you'll get the number back on the left. Right? So if I said, what would 0.5, if I inverse sine on that, I'd get 30. This one, we rounded off. So you might get back like 64.9 or something like that. Okay, but the other two were exact. Okay, let's try 150. Sine of 150 is 0.5. Okay, what just happened there? Where have we seen that answer before?
30 degrees.
Yeah, it's the same as 30. Okay, well, now that's kind of a problem. Because if I said to you, if I just showed you this table and said, if I type in inverse sine of 0.5, well, based on this table, there's two answers. The calculator is going to give you one. In fact, we already know which one the calculator gave us. Which one did it give us, 30 or 150? 30. It gave us the 30, not 150. All right. And to show you why it's giving us that one, we're going to look at a picture. It's like this. Okay, how many people have seen the picture of sine before? Anyone ever seen that? That's what sine looks like if you graph it on the calculator. Right? It's not a straight line. It's not a parabola. It's got this wave to it. Right? And if you take a horizontal line and you draw it through, would it hit this graph more than once? Yeah. That's why we're getting more than one answer. In fact, if I put a line right at, see if I can do it. That's 1, that's 0. There's 0.5 right there. First time it hits it is at 30 degrees. Okay, the next time it hits it is going to be at 150. But it's not just going to hit it twice. I could keep going. It's going to hit it again and again, and it's going to keep hitting it forever in each direction. Well, we gotta narrow this down so we only get one answer. We want everybody to agree and get the same answer. Right, so what we're going to do is we're going to kind of block out part of sine, right? And we're going to just focus on a very small section so that hopefully when I draw a horizontal line, it only hits it once. Okay, let's try it like this. Let's just look at that section. If I put a horizontal line in here, is it going to hit more than once? If I put it through that graph? Yeah. Okay, if we put a horizontal line, it does hit more than once. So looking at that's not going to work. Okay, let's try sliding it a little bit. How about like that? Would it still hit it more than once? Yeah, just barely. Let's go a little bit more. Let's put it right about there. Okay, now if I put a horizontal line, does it ever hit the graph more than once? No matter where I put it? You think, George?
No.
No. Right? So what we're going to do is when we answer questions about inverse sine, we're going to focus on just this part. We're going to ignore everything else. Right? right? So that way we're not going to get multiple answers. Okay, so we're between these two tick marks. You can see one there and one there. Okay, so this is what we're focusing on. Just that section right there. If there's any answer outside that green box, we're not going to write it down. That's the answers we're going to focus on. And these tick marks go by 90s. So this is 90, and this is negative 90. So when we do answers to inverse sine, okay, I want you to always give me an answer between negative 90 and 90. Right? And that's going to be important when we start using this chart. Because on the chart, you will find another answer. But if it's not between these two numbers, we're not writing it down. Okay, and if you're doing it in radians, that's negative pi over 2 to positive pi over 2. All right, so any questions about what I want the answer to be between when you do inverse sine? Okay, and this negative 90 to 90, the way we're limiting it, it's exactly how your calculator does it. So your calculator has to decide too, which answer should I give back? It does this. It says, is it between negative 90 and 90? If it is, then it tells you that answer. All right, let's try, let's look at cosine. All right, let me just get rid of this. Put that over there. And here's cosine. Okay, it looks pretty similar. In fact, you know what? Let me let's see if we can look at them both. See if you can tell the difference between them. Anybody see the difference between cosine and sine? It's the same basic shape, but how could you describe what's different here? Yeah, go ahead.
The sine is more like wider, it seems.
Wider? I can't really put them right on top of each other exactly, but they are, like if you were to measure, say, peak to peak here and peak to peak here, it would come out the same. They are the same basic distances and shapes, same height, but it's just, yeah?
Point where they cross the line.
Yeah, it's kind of like they start at different spots. Sine goes right through the origin. Cosine doesn't. Cosine starts up at 1 and then comes down, back up. Sine starts at 0, goes up, and then back down, and then back up. All right, so same basic shape. Let's try that negative 90 to 90, all right, because we've got the same problem here. If I put in a horizontal line, it's going to hit it more than once. Every single spot that it's hitting it at is an answer. But we got to narrow it down. We only want one answer, not 6 or even more. Let's take a look at this. Okay, I'm going to try looking at it from negative 90 to 90. Let's look at that. Okay, does that work? Does a horizontal line only hit that one time? No. So what that means is if we decide to limit our answers to negative 90 to 90, we're going to get 2 answers. Okay, so that doesn't work. All right, so let's just try positioning it somewhere else. How about like that? Does a horizontal line only hit that once? Yeah. So what we're focusing on now is this area right here. Any guess what those marks are? From this mark to this mark. Well, how about the one on the left?
0.
Yeah, that one's 0. And how about this second mark right here? 180. All right, so as long as for cosine, if we limit our answers to be between 0 and 180, you're only going to get one answer. So that's what you want to do for inverse cosine. Okay, and if you're working in radians, that's 0 to pi. And our last inverse trig function we have a button for. That's inverse tangent. Okay, inverse tangent, that one looks a little different. It's not a nice and connected wave. Okay, anyone ever seen that graph? No? Let's take a look at it. It's not a graph we spend a lot of time on in this class. It's something I do more in pre-calculus. But let's look at it. There's definitely a pattern to it, but it's just kind of like these repeated curves. But still, same idea. If I drew a horizontal line, would it hit those blue lines more than once? Yeah, everywhere it hits it would be an answer. So what we can do is we can narrow down where we're going to look. And this time we're going to look in this area. Whoops, a little bit off. What I just put a green box around. That's negative 90 to 90. If you focus on what's in that green box and eliminate everything else, you only get one answer. Right, so for inverse tangent, we're back to negative 90 to 90. What's the difference, though, between the numbers I have for inverse sine and inverse tangent? Very, very small difference, but it's important. You see the difference? They're both negative 90 to 90, but there's a very, very small difference. Rachel? Oh, did I forget? Thank you. That's very important. Yeah, I should have degree signs. That's perfectly valid answer to my question. And the top one, thank you.
It's not less than or equal to.
Yeah, that's what I was really going for, though. It's not less than or equal to. All right. So with inverse tangent, it cannot equal negative 90 or positive 90. A couple ways you can see that. One, let's try to let it equal 90. Let me type 90 into my table and watch what happens. At 90, it says error. Can't do it. At negative 90, it says error. So I cannot equal negative 90 or 90. I can get very close to it, like 89.9. Notice what happens to y. Look how big y gets. Okay, as you get very, very close to 90, okay, as you get very close to that mark right there, this graph is going way up. Very, very steep. How about as you got close to negative 90? It's not going up, it's going which direction here? Yeah, it's going way down. So if you typed in like negative 89.9, it'd be down at like negative 500. It goes down very steep. You could also look at your chart. Look at 90, look at tangent, it says undefined. Okay. So you don't even have to remember that you can't use negative 90 and 90. It says it right on the chart, undefined. Okay, any questions on these intervals? Okay, make sure you have those because we're going to use them in a little bit. All right, so really we've got to know when do you use this chart. Okay, this chart doesn't do everything for you, but there are certain times you want to use it. Okay. You want to use this chart if you're going to get an answer that's a multiple of 30 or 45. Those are the only ones that are on this chart. But that's a little tricky to know what your answer is going to be before you do the problem. How do you know ahead of time if your answer is going to be a multiple of 30 or 45? Well, the only way you can tell is in the question, look for numbers like I have in parentheses here. Okay, if you see numbers like 1/2, 1, anything with a square root 3, a square root 2, these are all the numbers we did when we did unit circle trig last week. You'll find all these numbers on this chart. All right, so if you see a number like this, that's when you want to look at this chart. And the answer will be a multiple of 30 or 45. Okay, if the answer is not a multiple of 30 or 45, we're going to use the calculator. Okay, and that'll be the last thing I show you how to do. Okay, just type this in on the calculator. something to kind of think about though before we get to the calculator. How many inverse trig functions do I have on this calculator? Just 3. Inverse sine, inverse cosine, inverse tangent. In fact, pretty much everybody's calculator, I would bet, just has these 3. There's no inverse secant, inverse cosecant, or inverse cotangent. We can still use the calculator to do it. Okay, I'm going to show you how that works. That'll be at the end, very last thing we do. All right, so questions on when you use this table and when you don't. All right, so I'm going to just try to put this in perspective, kind of what we did last week, what we're doing this week, and how they're different. All right, basically what we did last week and what we're doing this week are the opposite of each other. Okay, kind of the opposite kinds of questions. This is what we did last week. Right? I gave you an angle, like 30 degrees, and I asked you to find a trig function of 30 degrees. I could have asked you for sine, cosine, any of them. Right? So, just as an example, sine of 30 degrees equals what? And you gave me that. Okay, that's unit circle trig. Okay, what we did last week. Okay, this is what we're doing with inverse trig. Okay, this is this week. Instead of you giving me the question mark, I'll tell you the question mark. I'm going to ask you for the angle. That's what you're finding this week. All right, so I'm asking you, what angle would I take the sine of? And the answer would come out to be 1/2. And that's where this chart is going to come in handy. And I'll show you how we use the chart to find the answer to this. Okay, any question on the difference between what you did last week and this week? Okay, so last week I gave you the angle, and you told me what was on the right-hand side. This week, you're going to give me the angle. I'll tell you what goes on the right-hand side. All right, so it's kind of the opposite of what we did last week. All right, so let's try some examples. All right, way you use this table. Look at your trig function. Okay. Find the column for that trig function on the table. Look at the number in parentheses. Go down that column until you find that number. All right, so we'll do the first one together. I'm looking at the front, going down the sine column. I find a 1 across from 90 degrees. And that's it. That's the answer. 90 degrees. Okay. Or, if I was going to write that in radians, what's 90 degrees in radians? Pi over 2. It's right on the sheet for you. Okay, so unless they tell you degrees or radians, you can do it either way. Do it either way. Okay, any question how we got that? Let's try this one. So we're looking at the sine column. You're going to go down the sine column till you find a -1. And keep in mind, what did we say our answer has to be between for inverse sine? Negative 90 and positive 90. So if you find an answer that's not between those two, don't say it to me. Keep looking till you find negative 90 to 90. And if it's not on the front, look at the back. Okay. Anyone think they found it?
Yeah.
Yep, Jacob. Yeah, this one would be negative 90. Now that's also the same as positive 270. Why didn't you say 270? Yeah. Okay, we got to go with the answer that's between negative 90 and 90. Otherwise, we're all going to have different answers. Right? But I guarantee if you go between those two numbers, everyone, if they do it correctly, will have the same answer. Question on that one? Let's try this one. Okay, so another way to think about this question is I'm saying the sine of what angle would come out to a half? The sine of what angle would come out to a half? This is the question you're answering when you do inverse trig. Okay, anyone think they got it? Tom, did you think you got it?
Yeah, cos 30.
Yeah, I think we did this one when I was doing the table. This one's 30 degrees. Or can you tell me what that would be in radians, Tom?
5/6.
Yep, pi over 6. Either way.
There's two of them.
Is there another one?
Yeah.
All right, so go ahead. Somebody tell me the other answer.
150.
Yep, 150 is another answer. But is that between negative 90 and 90? No. So we're not going to use that one. Okay? All right. Any question? Because that's important, how George found that other answer, but the reason why we're not using it. All right. Okay, try that one. Inverse sine root 2 over 2. Okay, we'll find the correct answer, and then we'll write the other answer just to make sure people know where it is. So what's the correct answer here? Inverse sine root 2 over 2. Yep, Brandon?
45.
Yep, it's going to be 45. Okay, that's the same as negative 315, but that's not between what we wanted. And does anybody see where else it happens?
135.
135, which is the same as negative 225. Again, neither one of those are between negative 90 and 90. Okay, questions on that one? So that's the angle. If you take the sine of 45 degrees, the answer is root 2 over 2. Okay, and last one for sine. Okay, the sine of what angle would give me negative root 3 over 2? You're finding that question mark. And don't forget, there is a negative in front of that. How about someone, you guys are doing great. Just ask a couple different people here. How about, yeah, Amanda?
Negative 60.
Yeah, it's going to be negative 60. Right, if you go on the back, go down the sign column till you see this number. It's right at negative 60. Right, so any questions on how to do that for sine? That's all there is to it. All right, for cosine, now we've got to kind of switch gears a little bit. We're not negative 90 to 90 anymore. What are we now? Yep. Now we're 0 to 180. If you try negative 90 to 90, you're going to get hung up here. Okay, so now we're 0 to 180. All right, so what angle would I take the cosine of? And the answer would come out to 0. 90. Yep. Okay, which is the same as negative 270, but that's not what we want. And if you look on the back, you'd see another answer at 270 or negative 90. Neither one of those are what we want either. Okay, how about inverse cosine of negative a half? Oh, Jane?
Negative 30.
Let's see, negative 30, so you're on the back. Let's see.
Second to last one.
Okay, make sure which column are you in? Are you in the second column?
Sorry, I'm in the.
And just make sure, yeah,
Negative 120 then.
let's see, negative 120. All right, so I agree. I mean, if you take the cosine of negative 120, you will get that.
Yeah.
Take the cosine of negative 120, you do get negative a half. Okay? The only problem is that's not the one that's between the two numbers we're looking for. So we're looking for one that's between 0 and 180. Anybody see the one that's, and I think this one is on the front. Negative which one? Careful, two things there. One, that's not between 0 and 180, and you're looking at positive a half. Yep, Amber.
Isn't it just 120?
Which one?
120?
Yeah, it's 120. Okay, remember, cosine, you're looking to be between 0 and 180. Go down the front till you get to the fourth row from the bottom. Okay, 120. Okay, again, a lot of you guys said other answers that could work. It's just not the one that we want to say. Okay? And the way that I'm having you say this between certain numbers, it's exactly how your calculator does it. So I'm having you do it the same way your calculator would. Okay, and last one for cosine, negative root 2 over 2. Okay, really, for cosine, you shouldn't even be looking at the back. 0 to 180 is all on the front. So don't even flip it over for cosine. Yeah, Brandon?
135.
135, yes. And what would that be in radians, Brandon?
Be 3 pi over 4.
Yep. Okay, I want you to just get used to writing it either way, because on the test you won't know which way I'm going to ask for. But I'll write it in the directions. Okay, questions on inverse cosine? All right, let's just try a couple with inverse tangent, and then we'll try the calculator. Okay, try those two on your own. See if you can find the inverse tangent of square root 3 and inverse tangent of negative root 3 over 3. Okay, just remember you're switching gears again. What numbers are we between now?
Negative 90 then.
Yeah, now we're back to negative 90 to 90. We just can't equal negative 90 and 90. But on your reference sheet, it says undefined. So you don't have to worry about that. Okay, so take a minute and just try those. All right, so how about inverse tangent square root 3? Okay, anyone think you got that one? Yep, Tyler?
60 degrees.
Yep, 60 degrees. Or pi over 3 radians. And you could always check your answer. You could try typing this in and double check it. How about inverse tangent of negative root 3 over 3?
Negative 30?
Yep, looks like negative 30. Good. Okay, any questions on that? Or anybody not seeing where we're finding these answers? All right. So this is great as long as you're going to get an answer that's a multiple of 30 or 45. Okay, if not, we're going to use a calculator. Right, everyone's calculator is a little different. The directions I show you are going to work for graphing calculators and this kind of calculator. Okay, just the scientific one. All right, 0.65. Okay, you could try to use the table I gave you. But if you look for 0.65 in the sign column, you're never going to find it. Okay, it's not going to be listed on this table. All right, first thing, anytime we do inverse trig and it's not on this table, it's an approximation. Okay, we're going to have to round it off. All right, and what you want to make sure, check the directions on the problem. If it says degrees, put your calculator in degrees. If it says radians, put in radians. This one doesn't say. Okay, so I'll show you how to do both. Okay, let's start in degrees. All right, so if you're not in degrees, on a graphing calculator, you press mode, and then go down to degrees and just highlight it, hit enter. On this calculator, the scientific one, press DRG. If you press DRG, it gives you 3 choices: degrees, radians, and gradients. Okay, the first one is degrees. You just hit enter. All right. How did I say, what button do you have to press to get to the inverse functions? Yep, press second, and this time we want sine 0.65. Okay, and there's our answer. Okay, 40.54 degrees. Want everyone to understand, this right here is just a number, 0.65. It's not a degree, it's not a radian, it's like if I counted how many people in this room, just 20, just a number. It doesn't have a label of like feet or inches or gallons, okay, just number 20. Well, this is the angle. Okay, so in here is just a number, your answer is an angle. That's degrees or radians. Okay, if we did it in radians, you don't have to change how you type anything in. Just change the mode. Put it in radians, type in the same thing. Okay, so if you got 0.71, you're not wrong. You just did it in radians. Okay, questions on that? Now, let's say you saw these answers on a test. Okay, and I promise there's going to be only one correct answer here. So I want you to pick which answer you think is correct. A, B, C, or D. Which one is correct there? Just take a second to look at it. Tyler? C. Yeah. What other answer do you think some people might have been thinking in their head?
B.
B. Why is B wrong?
Because it doesn't have the degrees.
It doesn't have the degree sign. The answer was 40.54 degrees, not radians. Now, what if I did this? Now, B is the correct answer. That always trips people up. Okay, and on the multiple choice, they are going to do stuff like that. So just make sure you look. Are the answers in degrees or radians? I've had some people get that whole section wrong on the test. Super easy questions. Just had your calculator in the wrong mode for every problem. Okay? So be very careful with that. All right. Let's try inverse cosine negative 0.24. Okay, again, you can look at the chart. It's not on there. So just type it in. All right. If someone can type that in and tell me what we get, just round to 2 decimal places.
Do you want any degrees or radians?
Let's just do degrees. That's fine. Yep,
It's,
what'd you got?
103.87.
103.87. Okay, anybody else get that? No?
Yes.
Yes? Okay. Thank you. All right. If you're getting stuck, let me know. Because these are the easy ones. All right, now let's try one more easy one. Inverse tangent of 34.3. Okay, as this number starts to get bigger and bigger, the answer is going to get closer and closer to 90. So I'm thinking this is close to 90, but probably a little bit less. Yep. 88.3. Okay. So any questions on inverse sine, cosine, or tangent? All right, so the last 3. Inverse secant, inverse cosecant, and inverse cotangent. Okay, what we'll do is we'll look at one, just kind of in general. Okay, no specific values for x and y. We'll go through it, and I think you'll see the pattern of what you need to do. Okay, you're not going to have to go through it like we're about to every time. Okay, but we gotta see how to do this. All right. Well, first thing is, if I have a button for inverse secant, I can just use it. Is there a button on that calculator for inverse secant? No, there isn't one. Some calculators might have them, but most don't. Right, so what I'm going to do is I'm going to start by going like this. Take the secant of everything that's on the left and just squeeze it in right there, everything that's on the right. Okay, we haven't learned this, but you're allowed to do a trig function on both sides. Just like you can add a number to both sides, you could take the square root of both sides. Well, you can take a trig function on both sides too. Just got to do it on both sides. Okay, look at this left-hand side. What do you think is going to happen when you have secant and inverse secant next to each other like that? Yeah, they cancel out. It's like putting +2, -2. Two things that are opposites right next to each other. Secant, inverse secant. Okay, that's gone. So now we have x equals secant y. All right. So remember, my goal is to find a formula for y. Okay, that was the original problem, to find the inverse secant of x. All right, next step. I want to get rid of secant. I want to change this into a trig function that I have a button for. What can you do with secant? It's something we can do with it so we can type it in and we have a button for it. Remember what we did last week? There's a certain...
1 divided by the sine and cosine.
Yeah, cosine. We can use cosine. So if we take and flip it, if you flip the secant, the trig function you change it to is cosine. But if you're going to take and flip what's on the right, what else do you have to flip? Well, you have to flip what's on the left. Okay, so what we just did is we just flipped both sides. If you flip secant, you get cosine. If you flip cosine, you get secant. Okay. And now my last step, I want to get y by itself. How can I get rid of this cosine? I can't divide by it because it's a word. But it's kind of the same idea that I did up above. George?
You could do the cosecant negative, or the inverse.
Yeah, the inverse cosine. Right, so our last step, take the inverse cosine of what's on the right, do it on the left, and look what happened. Okay, we've got a formula for y. We have y by itself. That's exactly what we had to start with. But look what's on the left now. Inverse cosine of 1 over x. Do we have a button for inverse cosine? What do you think? Do we have a button for that?
Yes.
Yeah, we have a button for that. So now we have a new formula for y. And this was our original. Secant x equals y. So what do you flip here? You end up flipping something when you type it in. But do you flip the whole trig function or just the letter inside?
Just the letter.
Yeah, you just end up flipping the letter or the argument inside. Right? So if you see, just make sure we know, if you see inverse secant, okay, that one you use inverse cosine. If you see inverse cosecant, which trig function would you use for that one?
Sine.
Yeah, inverse sine. And if you see inverse cotangent, which trig function would you use for that? Inverse tangent. Okay. So these are the ones you have to change it to. So you change it to that function and then just flip what's inside. Okay, it's very, very simple to do once you learn that. It's all in the calculator. It's nothing you do by hand. You just have to remember how to do it. Okay, so start with inverse secant. Okay, first thing I check, is it in my list? No, it's not in my list. Okay, do I have a button for it on the calculator? No, so I got to change it. Rachel, what do we change inverse secant to? Which trig function?
Cosecant.
Nope, not cosecant.
I mean, that CO thing over.
Yeah, inverse cosine.
Yeah.
All right. So change it to inverse cosine. And now it's not going to be 1.45. What is that inside going to become? Yeah, you got to flip what's inside. That's how you do it. Okay? So change the trig function to the one I just said to. Take what's inside and flip it. And now just type it in. Okay, so inverse secant of 1.45. That's inverse cosine. Just like that. Okay, for division, make sure you use the divided by sign. Some people have a fraction button. It says like ABC. That doesn't work. Okay, just use your divide by sign. Okay, and we get about 0.81. I think that's probably radians. Yep. Okay. Or if you did it in degrees, just change to degrees. It's 46.4. I'm not going to do each one in degrees and radians, just this one. Okay. Any question on that? All right, so try the last two on your own. Okay. Try to find inverse cosecant of 2.6 and inverse cotangent of 0.35. Okay, if you get stuck or you're not sure how to do it, just call me over and I'll come help you out. How about Bruce, can you walk me through what I do to find inverse cosecant at 2.6? All right. Well, do we have a button for it?
What?
Do we have a button for that? What are the three that we have buttons for on there? Which three inverse trig functions?
Sine, cosine, tangent.
Yeah, we got sine, cosine, and tangent.
Yes, we don't have one.
Yeah, so we don't have a button for this one. Right? Who can help Bruce out and tell me what function do you use instead of inverse cosecant? Yep, inverse sine. Okay. Now you can't just use inverse sine. You got to use that and do one other thing.
You have to flip what's in the parentheses, so it'll be 1/2.6.
That's how you have to type this in. Okay, unless you've got some other fancy calculator that we don't, there's no way to type this in directly. Right. Inverse sine 1/2.6. Okay. Anybody else get that? 22.62? You people? Okay, good. Okay, if you got something totally different, it's possible you did it in radians. Okay, if you typed this in exactly just like that, you got something different, it's probably radians. Okay, and last one. Okay, Eddie,
Yep.
inverse cotangent.
It would be.
Do you have a button for that?
Oh yeah, no.
No.
You gotta do negative tangent, or tangent, negative, whatever, inverse.
Inverse, yeah.
Sure.
Inverse tangent. And Florencia, what do I do again here?
You put, you do 1/3.35.
1/0.35. Good. And now we can type that in because we have a button for it. All right. And anybody type that in and get an answer?
36.5 degrees.
136?
No,
36.5?
yeah.
Okay, anybody else get that? 70? Okay, well, let's see what happened. Inverse tangent, 1/0.35. 70.71, is that what people got? All right, so we'll have to see. I'm not sure what happened. Okay, so for the tests on Thursday, make sure you know how to use your calculator. Kind of stinks to get 6 or 7 questions wrong because there's no work to show. You just have to type it in right. There will be some ones that have work, but not these. Okay? So just make sure you know how to use your calculator. All right, so the homework, it's on 187. And a lot of it is calculator or just looking at the chart. So it's pretty quick. 13 to 17, 19, 20, 22 to 31, and 33.